Hey everyone, and welcome to this explainer. Today, we're going to completely decode the core components of the web. We'll be walking step by step through exactly what happens the moment you go online, and, most importantly, highlighting exactly what examiners are looking for. If you've ever wondered how typing a few words into a bar magically brings up a web page, or, if you're preparing to be tested on the invisible architecture of the digital world, you are absolutely in the right place. We're going to break down all those complex systems running behind the scenes into clear, totally manageable concepts. So here is our agenda for today. 1. Internet versus World Wide Web. 2. Browsers and URLs. 3. How DNS retrieves pages. 4. Securing data with HTTPS. And 5. Session and persistent cookies. All right, let's jump right into Section 1, Internet versus World Wide Web. It's incredibly common for people to use the terms Internet and World Wide Web interchangeably in everyday conversation, but technically speaking, they are entirely distinct. The internet is the actual physical infrastructure. Think of it as this massive global collection of interconnected networks and devices that rely on TCP and IP protocols just to communicate. It's basically the physical roads and highways. The World Wide Web, on the other hand, is just one single service running on top of that massive infrastructure. It's the collection of multimedia web pages that you access using web browsers written in HTML and communicated over HTTP. So going back to our analogy, if the internet is the physical roads, the web pages are the shops and buildings situated along those roads. Now, precision here is absolutely crucial. Listen up, because this is a master tutor tip taken directly from examiner reports. To really secure your marks, you always need to define the internet as the physical network of networks and the www as the collection of pages accessed through it. Literally, don't blend them together. Always treat them as the infrastructure and the service, respectively. Moving right along to Section 2, Browsers and URLs. Okay, so now that our digital world is built, let's put you in the driver's seat. To get literally anywhere in this landscape, you need a URL, the Uniform Resource Locator. This is simply the text-based address used to access a specific website or web page. And it's meticulously structured. It usually starts with a protocol like HTTP or HTTPS. Next up is the domain name, which includes the host, the domain type like .com or .org, and sometimes even a country code. And finally, you have the path or file name, which points to the exact directory and item you're trying to access on that server. It's essentially giving your computer exact GPS coordinates for a specific file. Naturally, you'd enter this URL into a web browser, right? But beware of a huge common pitfall that examiners constantly highlight. When asked about web browsers, so many students confuse the browser's main purpose with its individual functions. Let's make sure we separate what a browser is inherently meant to do from the little tools it gives you to do it. To be absolutely precise, the primary purpose of a web browser is to act as a piece of software that renders HTML to actually display web pages on your screen. That's it. It takes the code sent from the web server and translates it into a human-readable format made up of text, images, and videos. That is its whole reason for existing, translating and rendering. Meanwhile, its functions, the specific tools it provides to make your user experience better, are an entirely different story. These functions include things like storing your bookmarks or favorites, recording your user history, allowing the use of multiple tabs so you can hoard, 20 open pages at once, storing and managing cookies, providing navigation tools to move forward and backward, and of course, providing the address bar where you input the URL in the first place. Bottom line, if an exam asks for a purpose, talk about rendering HTML. If it asks for functions, pull from this list. All right, let's dive into Section 3, How DNS Retrieves Pages. So, you've typed your URL into the browser's address bar. What exactly happens under the hood to locate and retrieve that page? Well, humans are great at remembering text-based URLs, like google.com, but computers communicate using numerical IP addresses. Locating a page relies heavily on the domain name server, or DNS, which essentially acts like the internet's phone book. It follows a very strict sequence. First, you enter the URL into the browser. Second, because your browser can't locate the site with just text, it requests the matching IP address from the DNS server. Third, the DNS server searches its database, finds the match, and returns that numerical IP address back to your computer. Fourth, your browser now uses that IP address to send a direct request for the web page to the hosting web server. And finally, the web server sends the HTML data back to your computer, where your browser renders it. Which brings us to Section 4, Securing Data with HTTPS. once that web server is located and the HTML data starts flying back across the internet, we really need to ensure that transmission is safe from prying eyes, hackers or packet sniffers who might be intercepting data along the physical infrastructure. This is where transfer protocols come in. HTTP, or Hypertext Transfer Protocol, provides the basic set of rules for transferring files across the web. However, its secure counterpart, HTTPS, is what you absolutely need when dealing with sensitive information. HTTPS is the secure version that encrypts data using SSL, Secure Sockets Layer, or its more modern equivalent, TLS, Transport Layer Security. And here is a fantastic place to apply another Master Tutor tip. Encryption doesn't actually stop data from being intercepted. Rather, it scrambles the data into ciphertext, ensuring that if it is intercepted by a thief, the data is completely meaningless and unreadable to them. But how do your browser and the server actually agree on how to scramble this data securely? Well, this secure connection is established through a fascinating three-step process known as the SSL or TLS handshake. Step 1. Your browser asks the web server to identify itself. Step 2. The server responds by sending over a copy of its digital certificate. Step 3. Your browser validates this digital certificate against a list of trusted authorities. Once it's authenticated, a secure encrypted session begins. This entire invisible handshake happens in milliseconds, resulting in that reassuring little padlock you see up in your browser's address bar. And finally, Section 5, Session and Persistent Cookies. As you browse securely, websites interact with your machine, leaving behind small text files known as cookies, which are used to store your personal data and track your session. Now, please pay very close attention here. Examiners note a severe lack of detail in student answers when it comes to cookies. It is a trap so many candidates fall into. Most students simply describe session cookies as temporary and persistent cookies as permanent. While that's technically true in a broad sense, it will absolutely not earn you the full marks you're looking for, because it totally fails to explain where and how they are actually stored on the hardware. To get full marks and prove you truly understand the mechanics, you need to contrast them directly based on their physical storage locations. Session cookies are temporary files stored directly in your computer's memory, or RAM. Because RAM is volatile, these cookies are completely lost the second the web browser is closed. Persistent cookies, on the other hand, are permanent files stored directly on your computer's hard drive or secondary storage. Because they live on the hard drive, they are not lost when the browser closes. They just sit there until they either reach a set expiration date or they're manually deleted by you, the user. Remembering that difference between RAM storage and hard drive storage is the absolute key to mastering this topic. So the next time you hit enter on a URL, ask yourself, are you just looking at a web page, or can you now see the invisible matrix of DNS lookups, secure handshakes, and hard drive cookies happening in milliseconds? Cementing these concepts guarantees you those points in your exam, but honestly, more importantly, it means you'll never look at the internet the same way again. Thanks for joining me on this explainer, and keep questioning the digital world around you.